Just to finish up your notes for 5.3, this is what we saw in class today. I'm calling this the secret to all of integral calculus, is that we can evaluate integrals using antiderivatives. So if I want to find the integral from a to b of f of x dx, I can find any antiderivative of little f, and then evaluate it at b, evaluate it at a, subtract the two, and I'm going to have an expression for the area under the curve. So I'm going to do this example. Again, these are on the board in class today, but just in case you miss it. In the integral from 0 to pi of sine x dx, I think of an antiderivative of sine. So right now you know a few antiderivatives just by thinking about derivative rules that you know. And you know how to find some by undoing the power rule. In Chapter 6, we're going to learn lots and lots of techniques for figuring out other antiderivatives. But right now in Chapter 5, they should be kind of ones that you know, or ones that you can just think of, or ones that you can find by undoing the power rule. So I want to think what do I take the derivative of to get sine as the result, and that's negative cosine. So this is what I'm going to write here. Please notice this notation. This is going to be negative cosine of x from 0 to pi. That's that same tall line we've used before to mean evaluated at. But here we're going to have to evaluate at two values, the lower limit and the upper limit. So I'm going to write this is negative cosine of pi minus, please get in the habit of using big brackets or big parentheses after this minus sign. Doesn't happen to make a difference here. Negative cosine of 0, but you're going to be happy if you have the habit built. So negative cosine of pi is negative 1, so negative 1 is 1. This is the minus sign. Cosine of 0 is 1, so this is minus 1. That evaluates to 2. For this next one, an antiderivative for secant squared is tangent. So the integral from 0 to pi over 4 of secant squared x dx is tangent x evaluated from 0 to pi over 4. And that's going to be tangent of pi over 4 minus tangent of 0. There I am following my own advice and putting the big parentheses around that. Well, tangent of pi over 4 is 1. Tangent of 0 is 0. And the answer here is 1. For this last example, we're going to need to undo the power rule. We'll watch what that looks like. So if I need an antiderivative for 4x cubed minus 6x, so I'm going to say that is, I'm going to write the 4 and the x. I'm going to raise the exponent by 1 and divide by the new exponent. Minus, this is 6. I'm going to raise the exponent. It used to be x to the first, so I'm going to write x to the second and divide by the exponent. And I need to evaluate that from 1 to 2. Now here's an example where if you don't use the parentheses, you really could get the wrong answer. And they'll know that. That's going to be one of the multiple choice answers on a multiple choice section, just because it's such a common error for students to make. So you might like to simplify that first or not. It's really up to you. So that's x to the 4th minus 3x squared, evaluated from 1 to 2. So that's going to be 2 to the 4th minus 3 times 2 squared minus, big brackets, 1 to the 4th minus 3 times 1 squared. You can leave your answer like that on the free response section. If it's not the free response, you're going to have to simplify that out. 4 is 16, minus 3 times 4 is 12, minus 1 minus 3. 16 minus 12 is 4, minus, inside there, 1 minus 3 is negative 2. So 4, 6. The answer is C.